So isomerism means, iso means same, mer means molecular formula. Like इसको थोड़ा सा I'm going to make it easier. Isomerism is just like an isotopes. Like if you remember, we used to discuss isotopes. Isotopes means when the number of protons and electrons are same, but the number of neutrons are different. So it's called isotopes. Same goes with the isomer. In isomer, molecular formula is the same, but structure is different. You know, when the molecular formula is same and the structure is different, so we can say this is called isomerism. Um, we used to say that isotopes have the same chemical properties but different physical properties. You know why? Because in isotopes, as we have the same number of electrons, so that's why they have the same chemical properties, because chemical property is due to the number of electron, and the physical property is due to the number of neutron. Okay, so same goes with isomerism. As I told you that for the isomer, the molecular formula is same, but structure is different. Okay, so their chemical property would be the same, but physical property would be different. You know why? Because in chemical bonding we have discussed IMF is depending on the two factors: number of electrons and the surface area. When the number of electrons are higher, so the IMF would be higher. When the number of electrons are lower, so the IMF would be lower. First thing. Secondly, I can say when the surface area is higher, so the IMF is higher. When the surface area is lower, so the IMF is lower. So we have two factors on which IMF depends. Okay, so we will be discussing later on, but how can I define isomerism? Same molecular formula, but different structural formula. This is known as isomerism, and the molecule which would be having the different structural formula and the same molecular formula would be called isomer. Okay, the whole process is known as isomerism. There are particularly two types of isomerism. Number one is structural isomerism. Number two is stereoisomerism. Okay, number one is structural isomerism. Number two is stereoisomerism. So let's discuss first structural isomerism. What do you mean by structural isomerism? Structural, as the name indicates, same molecular formula but different structure. Okay, so let's say we have butane. Butane has four carbon atoms. Okay, butane has four carbon atoms. So you can see this is straight chain structure and this is the branched structure. What I did, I have drawn the three carbon atoms in a chain and one branch on the second carbon atom. So this is called branched structure and this is called straight chain structure. But the formula is same, C4H10, again C4H10. Name is also different. It's N-butane. N means normal butane, like a normal chain structure. And it's called 2-methyl propane. Name is different, but molecular formula is same. Structure is different, so they are called isomers of each other. They are called isomers of each other. Okay, that's known as structural isomerism. When the molecular formula is same, but the structural formula is different. This is called structural isomer. Since the formula is same, so means that the number of electrons are same, isn't it? If the molecular formula is same, so the number of electrons are same. When the number of electrons are same, so the IMF is same. IMF means I'm talking about the London force, because hydrocarbons are non-polar. Hydrocarbons are non-polar. So for the hydrocarbons, I can say they would be having a London force. And London force is depending on the number of electrons. Since the molecular formula is same, I mean to say 4 carbon atoms and 10 hydrogen atoms. So means that the number of electrons would be the same. And if the number of electrons would be the same, so the London force would be the same. But the thing is that they have different surface area. But the thing is that they have different surface area. You can see its surface area is higher and its surface area is lower. So we have to see multiple factors. We have to consider multiple factors. Remember. So if I will consider these factors, so I will come to know that the surface area for this molecule is higher. So I can say the London force is higher. So the melting and boiling point of this one would be higher. And if we talk about this one, since the surface area is lower, so the IMF is lower, like the London force is lower. When the London force is lower, so means that the melting and boiling point would be lower. So that's why I was saying physical property is different for these two, okay? But the chemical behavior would be the same. You know why the chemical behavior would be the same? Because the number of electrons, like they belong to the same family, I can say they belong to the same family. It's an alkane and it's also an alkane. Since they belong to the same family, they all are alkanes. So I can say the chemical behavior is same, but the physical behavior is different, totally different. Okay. So this is called structural isomerism. In structural isomerism, we have three types, or I can say there are three types of structural isomerism. Okay. There are three types of structural isomerism. Like we have, you can say chain isomer, we have positional isomer, we have functional group isomer. So first of all, you can see I have asked draw all the possible isomers of hexane. Draw all the possible isomers of hexane. The chemical formula for hexane is C6H14. This is the chemical formula for hexane. Okay. So what you have to do, you have to draw all the possible structures whose molecular formula should be the same, but structure should be different. What I did, you can see this is the normal hexane. This is the normal hexane. Okay, 1, 2, 3, 4, 5, 6 carbon. And this is going to be CH3. This is CH2. This is CH2. This is CH2. This is CH2. This is CH3. Since this is skeletal formula, so we are not supposed to show any carbon and any hydrogen. Okay, this is the normal hexane. And now what can I do for the next one? What I did, I have drawn the chain of 5 carbon atoms like that. You can count it 1, 2, 3, 4, and then 5. Okay. Chain of 5 carbon atoms. And this is the branch. So overall 6 carbon atoms. But you can see the name is different. So the name must be different for the structural isomer. The name must be different. Okay. If the name is same, so that would not be the structural isomer. Remember. So it's a good thing to give the name to the compound so that you can see in an easier manner that is that structural isomer or not. So that's why when I would be drawing the structure, so I would be giving the name. So the name must be different. Okay. So the name is different according to the rule, as I told you in the last class, IUPAC rules. So we have to select the longest carbon chain. So I have selected the longest carbon chain. After selecting, I came to know this is the branch. So then I have to number the number of carbon atoms 1, 2, 3, 4, 5. So I saw that the branch is present at the second carbon atom. So it's going to be 2-methyl pentane. Okay. And then this is the third one. What I did, I put the branch on the third carbon atoms. Rather than the two, I put the branch at the third carbon atom. Okay, so it's 3-methyl pentane. What it's 3-methyl and then pentane. Okay, so again the name is different. Again the name is different. So this is also the structural isomer of hexane, of course, isn't it? Then we have to go for the next possible structure. Then what I did, then what I did, I have drawn the chain of 4 carbon atoms. It was the chain of 5. It was the chain of 5. It was the chain of 6. So as we have to write down the possible structures, so what I did now, I have drawn the chain of 4 carbon atoms. So we have 2 remaining carbons. So what I did, I put the 2 branches. So in the previous structures, we had one branch, one branch. Then what I did, 2 branches. Okay. So now we have to give the name. So it's going to be 2,2 dimethyl butane. Before going to do structural isomer, you must know the IUPAC nomenclature of the compound. Otherwise, you will not be able to draw the like you will not be able to draw all the possible structures. It's mandatory to know the IUPAC name of the compound. Okay, it's mandatory. So, and then um, you can say this is the other possibility. One, two, three, four. Again, the chain of 4 carbon atoms. Okay, again, the chain of 4 carbon atoms. And then it's going to be we have the 2 branches, but at the different positions. We have the 2 branches, but at the different positions, right? So it's going to be 2,3 dimethyl butane. 2,3 dimethyl butane. Okay, 2,3 dimethyl butane. So these are the possible structures of hexane. So you can count the molecular formula is same, but the structural formula is different. The molecular formula is same, but the structural formula is different. Remember, okay? Molecular formula is same, but the structural formula is different. That's it. Now you can try pentane. Now you can try. Now you can try pentane. How many possible isomers we may have? You can try pentane. After drawing, then you can tell me. Then I would be drawing. Then you are supposed to match your structures with me. If they are matched, so that's good. And if not, then you have to look at all the structures. Start.
Sure, done.
So how many structures are possible?
Three structures.
Three possibilities, right?
Yes.
So, okay. Number one for the pentane. Number one for the pentane.
Sorry,
It's
four
pentane.
possible structures.
One, two, three, 4, 5. This is the first possible. I'm not going to write down the hydrogen atoms. It's understood. So it's pentane. It's a normal pentane. Then I'm going to draw the another possibility. 1, 2, 3, 4, and this is the branch. The name for this compound is 2-methyl pentane. Then I'm going to draw the third possibility. You know, I cannot draw this structure. Can you tell me, is that correct or not? Is this the third possibility or not? Yes or no? Like, should I count that this is 1, this is 2, and this is 3? Yes or no? Hmm? Mhm. Is that correct
Yes.
possibility? No, it's not correct. So
No.
that's why I was saying, that's why I was saying that whenever you are going to write down whenever you are going to draw the structure of any of the compound, so you must give the name to that compound. Otherwise, it's going to be difficult for you to identify the correct structure. So, if you will be giving the name to this compound, it's 2-methyl butane. It's also 2-methyl butane. According to the rule, we are supposed to give the lowest number to the branch. If this is 1, 2, 3, 4, so this is going to be 1, 2, 3, 4, because this is the branch and we have to give the least number to the branch. That's the rule. In both cases, the name is same. In both cases, the name is same. When the name is same, so it's the same structure. It's not an isomer. We need different structure. We need the different name. So this is going to be the same. So I'm going to erase this structure. We have to draw the unique structure whose structure is different, whose name is also different. But of course, molecular formula should be the same because they are isomers of each other. Okay. So we have to draw another structure for which the name should be different, the structure should be different, but the formula should be the same. So I can draw this one. I can draw this one. Okay, I can draw this one. Simple. Okay. So what's the name of this compound? Of course, this is going to be 2 comma 2 dimethyl propane. 2 comma 2 dimethyl propane, right? So this is the third one. So this is the third structure for this one. So there are only three possibilities that we can draw the structural isomer of pentane. If you are thinking that there are four possibilities, there should be the fourth structure, you can draw and share with me, then I will tell you why that structure is wrong. Again, I'm saying that you have to give the name to the compound. So after giving the name, the thing would be very easy for you. The thing would be very easy for you. So there are only three possibilities for the pentane. Okay. And there are 1, 2, 3, 4, 5 possibilities for the hexane. This is all about the structural isomers. Okay. Let's say if I give you, let's say if I give you for the practice, like heptane. For the practice, if I give you heptane, let's say heptane. Hept means 7 carbon atoms, right? It's going to be C7 and H16. C7 and H16. It's heptane. So how many isomers we can draw for the heptane? Like 7 carbon atoms. Yes? Okay, now I'm going to draw. You are supposed to match your structure with me. Okay, so it should be number one, normal structure that is going to simple heptane. I'm going to draw the skeletal formula. It's more shorter. One, two, three, four, five. If you can count, one, two, three, four, five, six, seven. Okay. After drawing the first structure, then I'm going to draw the chain of six carbon atoms. One, two, three, four, five. I'm going to draw the chain of six carbon atoms rather than seven. Okay. Then I'm going to draw the one branch on this carbon atom. So it's going to be 2 methyl. I'm going to write down the name as well. Okay. I'm going to write down the name as well. It's normal heptane and it's 2 hexane. It's 2 methyl hexane. Okay. And then, what about the third one? I changed the position of the branch, isn't it? One, two, three, four, five, six. I'm going to write down the branch over there. It's gonna be 3-methyl hexane. 3-methyl hexane. Okay. It's gonna be 3-methyl hexane. Then I'm going to draw the fourth structure. Then I'm going to draw the fourth structure of uh, heptane, I can say. Now I cannot change the position of the branch because it should be the same. Like, say I cannot draw this one. I cannot draw this one. You know? You know why? Because if you can count one, two, three, again it's going to be 3-methyl So it's not possible. Again, I'm saying that the name should be different, the structure should be different, but the molecular formula should be the same. So then what can I do? I'm supposed to decrease the main chain. Like now I'm going to draw the 5 carbon atoms, okay? One, two, three, four, five. And then remaining carbons are 2, so I'm going to draw the branches like that. So it's going to be 2 comma 2 dimethyl 2 comma 2 dimethyl pentane, isn't it? Then I'm going to draw the next one that's going to be again the 2 branches I'm supposed to write. So 1 and then 2. Okay. So what's the name? 2, 3 dimethyl pentane. Okay, 2 comma 3 dimethyl pentane. Now what's the next possibility? So I can draw this one. I can draw this one. It's going to be 3 comma 3 dimethyl pentane, comma 3 dimethyl and then pentane. Now I cannot, yeah, I can also change the, I can do this one as well. I can draw this one as well. It's gonna be 1, 2, 3, 4. 3 comma 4 dimethyl pentane. Dimethyl pentane. Okay. Dimethyl pentane. Now, what's the other possibility? This would be the number 8. This would be the number 8. So what's the possibility for the next one? So I can say that I'm supposed to write, I'm supposed to decrease the main chain, that is 1 rather than 5. How many carbon atoms are remaining? 3. So I'm going to put two branches over there. I'm going to put one branch over there. It's gonna be 2 comma 2 comma 3 trimethyl, but this is butane. But this is butane. What's the other possibility? It would be 9. Okay, it would be 9. So I can say that uh like um okay. What it would be 1, 2, 3, 4. Um 1, 2, 3, 4. So 1, 2, 3, 4. It's not 3 comma 4. It's not 3 comma 4. It's 2 comma 4, isn't it? It's 2 comma 4. It's 2 comma 4 dimethyl. If you can count 1, 2, 3, 4, 5. Dimethyl pentane. Okay. Or what's the another possibility? Because I cannot change the position of the branches. This is already full. If you are thinking that I can change, so you just change and give the name to that compound. If the name is going to be matched with the given structures, so that isomer is not possible. It's simple. It's simple. Okay. I can also do like that. This would be the last structure, of course. Let's say I'm going to draw this one like that, and this is going to be like that. 1, 2, 3, 4, 5, 6, 7. So what's the name of this compound? What's the name of this compound? So I can say that uh, it's going to be um, 3-methyl butane. Okay, possible structures of heptane. Like in the exam, you will not see so much long isomer question, but for the practice, I told you this one to to get your like to make your concept in a better way. That what's the criteria that we are just looking at while we are drawing the isomers. So the thing is that first of all, you have to draw the structure and then you have to give it the name. The name should be different. If the name is same, so isomer is not possible. And that's it. And that's it for the structural isomer of alkane. Okay. So it starts from the butane. It starts from the butane because butane has two isomers, then butane, pentane, hexane, heptane, and so on. Okay. So then we have to discuss the structural isomer of alkene as well. As I told you at that time, there are three isomers. Like there are three types of structural isomer. Number one, chain. Number two, positional isomer. And number three, functional group isomer. Because in an alkene, there would be a double covalent bond. So then we have to mention the position of the double covalent bond, whether the double covalent bond is present at the first carbon atom, whether the double covalent bond is present at the second carbon atom, on the third carbon atom. So that's why it would be lying in the category of positional isomer. We have to give the, you can say, we have to mention the position of the double bond. Okay, so that's why. But in an alkane, it's a normal structure. We have to only look at the chain isomerism. So I mean to say the molecular formula for all is the same, but the length of the chain is different. The length of chain is this one, 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 the length of chain is this one. So the length of chain is different, like the chain is different, but the molecular formula would be the same. So this is called chain isomerism. Okay, this is called chain isomerism.